Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about building materials. Manufacturing of bricks. Manufacturing of bricks. The process of manufacturing of bricks is carried out in a number of stages. These are listed below. Each stage has its own specific importance. Stage 1. Selection of the suitable type of brick earth. Stage 2. Preparation and tempering of mud. Stage 3. Shaping or molding of brick units. Stage 4. Drying of molded bricks. Stage 5. Cooling and burning of bricks. Stage 1. Selection of the suitable type of brick earth. Good quality building bricks cannot be made from every type of earth or soil. As a general statement, it may be said that any soil, earth, which contains 4 parts of clay and 1 part of sand is suitable for making bricks. This is, however, a general statement. A suitable earth should have various constituents in the following proportions. Alumina, 20 to 30%. All clays are basically hydrous aluminum silicates. Clays are responsible for the plastic character of the mud. If they are present in higher proportions, the brick will shrink on drying, and develop cracks. If they are present in smaller proportions, the brick will not be molded easily and nicely. The above percentage of alumina, 20 to 30%, imparts the bricks sufficient plasticity. Silica, 50 to 60%. This is present in 2 forms, the silica combined as a constituent of clay, and the free silica, sand or quartz. The total proportion of silica should form about 50 to 60%. It is why the actual clay content and free sand content has to be broadly in the ratio of 4:1 in the good brick earth. Silica is responsible for strength, hardness, and resistance to shrinkage and shape of the brick, and, also to a great extent, for its durability or long life. Lime, 4%. This component makes burning and hardening of bricks quicker and therefore is considered desirable with following 2 conditions. A. It would not be more than 4% because in that case, it may cause excessive softening of bricks on heating. Lime and magnesia act as fluxes. B. It must be present only in a finely powdered and thoroughly dispersed form. Otherwise, if present in small grains or nodules, the lime itself will get slaked, heated, and once the brick is used, lime, will easily get hydrated and cause disintegration of brick. Iron oxide, 4 to 6%. Like oxides of calcium and magnesium, iron oxide also acts as a flux, i.e. it lowers down the softening temperature of silica. The iron oxide has, in addition, another important function: it imparts the red color to the bricks. The excess of this oxide will make the bricks too soft during burning, where there is a risk of deformation, besides making them darker in appearance. A shortage of iron oxides in the earth will affect the final color of the bricks. Instead of being brick red, they may be yellow or light red. The yellow color may also be due to incomplete burning of bricks. Stage 2: Preparation of brick earth. The following sequence of operations involved in preparation of brick earth: unsoiling, digging, weathering, blending, tempering. Preparation of brick earth. Following are the various operations involved in preparing brick earth. Unsoiling. The soil used for making building bricks should be processed, so as to be free of gravel, coarse sand, particle size more than 2 mm, lime and canker particles, organic matter, etc. About 20 cm of the top layer of the earth, normally containing stones, pebbles, gravel, roots etc. is removed after clearing the tree and vegetation. Digging. After removing the top layer of the earth, proportions of additives such as fly ash, sandy loam, rice husk, stone dust, etc. should be spread over the plain ground surface on volume basis. The soil mass is then manually excavated, puddled, watered and left over for weathering and subsequent processing. If the area from where soil is to be taken is grassy or has other vegetation, then the top layer, about 20 centimeters deep, is excavated and thrown away as it contains roots of vegetation and other organic matter. The excavated lumps of soil are broken. It is ensured that the soil is free from gravel, coarse sand, lime, and canker particles, vegetable matter, etc. Weathering. Excavated soil, after the clods have been broken, is mixed with a little water and is left in heaps to weather for a period varying from a few weeks to as long as it can be left. This improves its plasticity and strength. Stone, gravels, pebbles, root, etc. are removed from the dug earth and the soil is heaped on level ground in layers of 60–120 cm. The soil is left heaps and exposed to weather for at least 1 month in case where such weathering is considered necessary for the soil. To keep the soil wet, water may be sprayed on the heap from time to time and heap turned over. Blending. The earth is then thoroughly broken and mixed with sandy soil and calcareous earth in suitable proportion to modify the composition of soil. Moderate amount of water is mixed so as to obtain the right consistency for molding. The mass is then mixed uniformly with spades. Addition of water to the soil at the dumps is necessary for the easy mixing and workability, but the addition of water should be controlled in such a way that it may not create a problem in molding and drying. Excessive moisture content may affect the size and shape of the finished brick. Tempering. Tempering consists of kneading the earth with the feet so as to make the mass stiff and plastics. The whole mass becomes homogeneous and plastic. It is then left covered with mats and allowed to dry gradually in layers about 30 centimeters thick for not less than 36 hours, till it is just soft enough for molding. Tempering is done in pug mill and the operation is called pugging. The yield from a pug mill is about 1,500 bricks. Stage 3 Molding of bricks. Molding is the process of making properly shaped brick units from a thoroughly tempered clay. There are two main methods of molding. Hand molding, when the job is done by skilled persons. Machine molding, when specially designed machines are used for molding of bricks. In most countries, even today, the most common method of molding of bricks are hand molding. In the advanced countries, however, mechanized brick making is the main process for large-scale manufacture of bricks. Stage 4 Drying of bricks. After molding, the green bricks have to be dried. This is necessary for three reasons. Firstly, to make them strong enough for rough handling during subsequent stages, as for examples for stacking, etc. Secondly, to allow a slow loss of moisture from the brick without disintegrating the unit. If a green brick is put to direct burning in a kiln, the rate of loss of moisture will be so fast that the brick will crack during the burning process. Thirdly, to save fuel during the burning stage, a brick containing 20% moisture will require more fuel to burn compared to a brick containing only 2 to 4% moisture. Drying of bricks is achieved either by natural methods or by artificial methods. In the natural drying method, there are two distinct stages. Pre-stacking stage, where the molded bricks are first laid edgewise, sidewise and flat for 2 to 3 days so that they become hard enough to handle without losing shape or breaking. Stacking stage, in which the hard bricks from the first stage are arranged in well-made layers, one layer above another. Stacking in the manufacturing of bricks is done in specially prepared drying grounds. Each stack may be about 20 centimeters wide and as long as the ground allows. The height of the stack is generally of about 10 brick layers. Enough space is left between the individual bricks in a stack and also between the different layers for easy circulation of air. It is absolutely necessary that drying should be done in stacks that are properly protected from direct sun and rain. Air drying by staking may take 4 to 12 days for reducing the moisture to 2 to 4% in the brick. This depends on time and place of drying. The artificial drying. This method becomes essential in mechanized brick-making plants. It is only by this method that the drying of bricks can be ensured throughout the year independent of weather conditions. Artificial drying may be done either in specially designed chambers or in tunnels. In the chamber drying, bricks are arranged in stacks with sufficient spaces in between them for free circulation of air. Hot air under controlled conditions of temperature and humidity is made to circulate through these stacks for 2 to 3 days or more. The dried bricks are then taken out and next batch loaded in the chamber. In the tunnel dryers, the brick stacks are made on vehicles that travel on rails within a drying tunnel. The tunnel is divided into compartments and the stack-loaded vehicles is made to enter from one end, stay in each compartment for a prefixed time and come out of the other end. This process may again take 1 to 3 days for a car load of bricks to dry to a required moisture content. Use of sun-dried bricks. The sun-dried bricks, also called adobe, are poor man's construction material even during the present time in many countries of the world. These bricks, when protected from rain, are strong and durable enough to sustain loads of small units in villages. Stage 5. Cooling and burning of bricks. This stage of manufacturing of bricks is absolutely essential to develop in them the desired building properties such as sufficient strength, hardness, durability, and resistance to decay and disintegration. At least 3 chemical changes are known to take place in the brick earth during the burning process: dehydration, oxidation, and vitrification. Cooling. In this stage of manufacturing of bricks, the burnt bricks are placed for some time to be cooled before using it in the construction. Burning. The burning of clay may be divided into 3 main stages. Dehydration. It is completed within the temperature range of 425–750 degrees Celsius. Bricks heated to this temperature lose all the free water and most of the water of crystallization. Oxidation. It also starts within the above range or temperature and is completed at about 900 degrees Celsius. All the organic matter in the brick earth gets oxidized. Carbon and sulfur are eliminated as oxides. The fluxes, lime, magnesia, and iron, also become reactive at this temperature. The brick acquires the red color due to oxidation of iron in the clays. Vitrification is the extreme reaction that takes place from 900 degrees Celsius to 1100 degrees Celsius or so. The constituents of brick clay, that is alumina and clay, start softening in the presence of fluxes and getting bound together firmly. In fact, this is the change which makes a brick a strong and hard unit. But when the brick is heated to the extreme temperature of vitrification, the fluxes may actually cause considerable softening of the essential components of the brick earth. At that stage, the brick may lose even its original shape and get distorted at edges and corners. Hence ordinary, building bricks are not heated to very high vitrifying temperatures. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.